here. Uh, we may have some questions, yes, because we scheduled for 1 hour. It got extended. We can ask uh, more questions today, friends, and we're gonna start with our agenda. We're gonna start with cloud. That's the first topic. So what I'm gonna do, I'll give you a walkthrough of the flow, how we are going to cover this entire course, so that you get a good clarity on things, friends. So the first thing, like we have got various modules in this course. The first thing, when you join, then you get enrolled. First of all, you would be in a added in a WhatsApp group. Those who the enrolled candidates, learners will be added to a WhatsApp group, and even I'll be part of that. And we'll be having the communications going, the links to join, about the schedule, any questions, how your practice is going on, any questions, any queries if you have, right? So we'll have a dedicated WhatsApp group uh, in next week. We'll be creating that. So the coming week we'll be creating that. So those who are looking to enroll, get it enrolled, friends, and ask questions or whatever you have. So the plan is to go in a very step-wise manner. Okay, the way it's going to work the best way for your learning experience, we will take that. So the first topic that we take is the cloud. That's how we start, and we cover from the basics, right? The From absolute basics. What is cloud computing? From there to various services, why we use cloud, what is the region, what is on-prem, what is the difference, what are different service models in cloud, SaaS, what is SaaS, infrastructure as service, platform as service, what is that understanding? If you want to get a server, how do you get it? How can you optimize the cost? So all the discussions that will take it up. See, anybody can teach cloud, but the way we talk about, the way we go about a topic, let's say EC2 or storage service, it will be with the mindset of performance engineering and SRE. Like we will talk about cost, we'll talk about security. That's going to be our, we'll talk about performance. That's going to be always the case for any service that we talk about. If you talk about EC2, I'll take you talk about various instance type. Why do you use a particular instance type? How can you optimize the cost? If you face a certain scenario, what would you do? uh, in detail. So just I don't want to talk about that right now, but all the discussions that we'll have is around these things, all the topics in the cloud. So that's what we go, and that's what it separates it from any other cloud courses, because you need to understand, if you know, let's say if I talk about EC2, EC2 is a service using which you get a server. How can you optimize the cost? How many different instance families we have? Why do you use a particular instance family? What is the thought process? When we get EC2, we also get the disk storage services. Why EBS? Do we have more storage classes, storage options like EFS or S3? So our entire discussions on the S3, how do you secure the storage? How do you secure the EC2 instance? And from the performance perspective, as I told you, the instance families, depending on the application, which instance type would you go with? So every discussion is around this. And we'll talk about a lot of things. One of the important things, we'll talk about VPC, networking, storage services. Now after we cover, let's say 2 weeks, we'll talk about the most important and the critical topic is the load balancer and auto scaling group, because it is this load balancer and auto scaling group that is the most important thing from a cost perspective, from the availability perspective, high availability perspective, because in the cloud, You will understand the difference. First of all, you need to understand the difference on-prem versus cloud. In on-prem, friends, I can tell you that we purchase all the servers. Like, what is on-prem? Let me tell you brief. What is the difference between on-prem and cloud? Data center you saw yesterday. What do we call a data center? A facility in the outskirts of a city, multi-story building. We have purchased the servers. So when you own every part of it, right from scratch, from procuring the land, constructing building, constructing all the servers, hardware, softwares. When you own everything, that's called on-prem. But when somebody else owns it, like AWS, Azure, and you leverage it, that's cloud. So in the cloud, we don't need to purchase all the servers. We need to auto scale the servers based on the load. And it should auto scale. If the load is less, see, look at any website, Flipkart, Amazon.com, the load is not consistent throughout the day. Right now, if I tell you Champions Trophy is going on in Hotstar, the load during the match is totally different on Hotstar. Hotstar is a streaming platform. So during the load, how they make sure that the users have the best experience. And they would not have the same servers configured apart from the Champions Trophy duration. They would have lesser servers because the not many people would go and stream things there as compared to during the Champions Trophy, particularly during the, let's say today's match is going on, India versus New Zealand. More people have was streaming. So how do they make sure that they only get servers during a specific time? Auto scaling. So they have auto scale based on the some criteria. So we'll discuss about that. That's very, very important topic to understand from a performance perspective, from a reliability perspective. We need to understand this. We'll talk about databases in cloud database options that we have. So a lot of things. Now, when we're talking about cloud, so cloud usually, friends, we cover approximately 3 weeks. Okay, dedicated to stretch straight 3 weeks, minimum 3 weekends. 3 weekends we start. And when we talk about cloud, you will be given access to the Linux recorded sessions, which I showed you yesterday. 3.5 hours of recorded sessions, and you're expected to go over it and ask questions in the session. If you have any questions, concerns, practice it. So we'll talk about how to get the server, and you can practice in the same server. So you'll be given the access at the same time. We don't dump everything, so that we want to have the best learning experience so that you know what needs to be done. So in a small portions, we cover it. So you'll be given access, right? The playlist, which I was showing you yesterday. I hope you remember that, right? If I show you again, if you go to the playlist, the Linux, this is the playlist I'm talking about. 3 videos here, 3.5 hours of sessions. Just enough information to get you started on Linux and shell scripting. Okay, you'll be given access to this and you can go over it, practice it, get comfortable, ask questions in the session. That's the thing. Now, after we complete the cloud, friends, we talk
Rashmi,
about
how can we practice the Linux? So how can
correct.
we get
So
the access to server?
correct. So when you talk about cloud, right, the first thing which I'm going to tell you about EC2 server on the day one, let's say next weekend itself, I'll talk about the EC2. So you can create your own server. Today, I'll show you how do you get the server. You can create your own server and you can practice. You can SSH connect to the server. Everybody is going to do hands-on, friends. Everybody is going to have this kind of cloud console. I'm going to guide you if you don't have it already. Everybody is going to do practice. Everybody will create the EC2 instance. You'll be comfortable creating the EC2 instance next weekend itself. And we need to SSH. You need to understand the difference. Why SSH to Linux? Why RDP to Windows? What is SSH? What is RDP? Which port we do SSH? Which port we do RDP? So like all those things, basics from scratch, we talk about. So you'll be practicing it. You will be creating your own server and you'll be practicing it. Now, after this, friends, we start our discussions on microservices. Microservice. Let's say microservices. Again, what from very scratch, what is microservices? How different it is from monolithic applications? First of all, from the understanding perspective, then where do we deploy microservices? So you eventually will discuss about something called container engine. We'll talk about Docker here. Container engine. What is container engine? How we can deploy a microservices. So we'll be deploying it, friends. We'll be installing container engine. We'll be containerizing a VM. We'll be creating containers, installing microservices. All these things hands-on. Everything is hands-on here. Our entire course is 90% hands-on, 10%. During the hands-on, I explain things. Every time you will see me executing commands, and that's why it's very important for you to know this. If you have not started, you should know this. That's why it's very important, indispensable for you to be comfortable with Linux, because you would be doing things in the Linux console. 95 to 98% of the deployment in the enterprise industry happens in Linux server, not in Windows. So we need to get comfortable. You'll be comfortable after 3.5 hours of sessions. You'll be comfortable with Linux as you are with Windows, right? If in Windows, if I ask you to open a file, edit a file, search a text in a file, zip a file, install a software, right? So whatever you could think of in Windows, we are doing the same thing in Linux, and that's what I have demonstrated that in a very step-by-step manner. Earlier, we should take that as a live session, but because of the time constraint and other topics, we have included other topics. So we have made it balanced. If not, our session will go for 6 months. We don't do that. So we try to complete within 2.5 months to 3 months. Anyway, it will go. So we'll talk about microservices, container engine. We'll talk about Docker is one of the container engines. How do we create containers and various things? Docker volumes, Docker compose, Docker file. You may not understand this if you don't know it, but you'll understand once I talk about it. We'll talk about Kubernetes. We create Kubernetes in the EKS cluster. We will create it, we'll deploy pods, applications, we'll export services using services. We'll talk about ingress, we'll talk about load balancer. We'll talk about auto scaling of VMs we talk about. We'll also talk about auto scaling of containers, HPA, cluster auto scaler, ingress, monitoring, Kubernetes monitoring. So all those things, friends, we'll talk about here. Once again, this is going to take complete 3 weekends, dedicated more also, but 6 sessions definitely required. Yes, 6 sessions definitely nobody can. Yeah, definitely it can be 7 sessions also, but 6 sessions definitely required. 6 to 7 sessions. Then we talk about, friends, DevOps. What is DevOps? What is the history of DevOps? SDLC, process, waterfall, agile, DevOps. We talk about how do we automate. One of the automations that we're going to learn here is CI/CD pipeline. We'll talk about Jenkins here. We'll talk about Maven here. You will understand how do you create a performance job. Like I'll be creating a Jenkins job, performance job, where I'll be triggering a Jmeter script. Jmeter script, how can you schedule it? You don't need to be in the server in the Jenkins machine to trigger it. From the Jenkins console, I can trigger a Jmeter script in another node, in another VM. We'll talk about CI/CD pipeline. You'll understand something called continuous performance testing in DevOps here. Again, this is going to take, friends, 2 weekends. Then we talk about SRE. We delve into SRE concepts. With a lot of terminologies are there. What is high availability? What is fault tolerance? What is disaster recovery? The deployment strategies, rolling update. What is rolling update? What is A/B testing? What is blue-green deployment? Disaster recovery. How do you make sure you do disaster recovery? How it works? What are different things you need to consider for disaster recovery scenarios?
In DevOps, are you going to cover the GitHub or no, sir?
Correct. GitHub. It's a part of GitHub, right? Because when I talk about CI/CD pipeline, the code is going to be in GitHub.
Okay.
We will create, yeah. So I'm just giving a brief for you to, but a lot of things. If you want to go in detail, you'll understand this. This link, if you go, you'll have detailed thing. I just want trying to be uh, high level here. But definitely, without GitHub, how would you? So we basically when what we do in pipeline, as soon as developer pushes the code to GitHub, automatically the pipeline will trigger. That's what we learn, and the pipeline would be created in Jenkins. We'll integrate Jenkins with Docker. We'll integrate Jenkins with Kubernetes. That's the pipeline thing. Right. So definitely 4 to 5 sessions, friends. It will be taking up 4 to 5 sessions. Then we talk about SRE, friends. SRE terminology. A lot of terminologies are there. You need to understand what is SLO, SLIs, SLAs, error budgets, mean time between failures. What is MTBF? In disaster recovery, you'll understand what is something called RPO, RTO, lot of things. Okay, a lot of things. When we talk about SRE, I'll be giving access to the Java performance engineering here, the recorded sessions. Now, this is the right time where I want you to focus on other things, and this is the right time you would explore the JVM architecture, various GC algorithms, parallel, CMS, G1, GC. What are different things we look into the heap dump? What is shallow heap, retained heap? How do you analyze a heap dump, thread dump, right? What is the importance of all these things? Why do we do that? So all those things you'll be given the recorded session here. So there are 2 recorded sessions. As I told you earlier, you should take the live session, but we have planned in such a way that we cover it, we complete this. So live sessions are 40 to 45 hours. Along with that, you can add 10 hours here, 4 hours here. So it will be much more. We talk about automations. We talk about a lot of things about automation. We talk about Terraform, which is used for the infrastructure provisioning. In production, friends, we have so many servers. We have so many resources. So do you think people are installing, deploying all the servers manually? No, we don't do that manually. We use something called Terraform script. Infrastructure as code. We write code as code. We write a script which should going to provision the entire infrastructure. Right? We talk about Terraform. We have something called Ansible configuration management. We'll talk about it. So this usually takes, friends, 2 weekends, one weekends, I would say, 2 sessions, 1 to 2 weekends I would put, depending on how are we doing as a group.
Hi, Roshan. Sorry to interrupt.
Yeah.
Yeah, regarding the SRE topics, do we have any practical sessions we've covered? or is it like
See,
all the
it's
theoretical?
see all are hands-on. Okay, first of all, SRE is not separate in itself. If I talk about Java performance engineering, which is hands-on, if I talk about automation, if you talk about cloud, if you talk about Linux, talk about Docker, Kubernetes, DevOps, is all part of SRE. So the what I'm
Okay.
talking about here is the concept perspective. Everything is hands-on here, but you need to also understand, right, that what do you define SLIs, SLOs, SLAs, mean time between failures? How do you do incident management, change management? So you need to understand this thing. You need to understand how disaster recovery works, how it happens. So it is going to be mostly the theoretical aspects here, because that's what
Okay.
required. But everything is hands-on here. Everything is hands-on, which is part of SRE. So it's a, you need to
Okay.
think from a complete course perspective, not what do we do on a particular topic, because we are doing it because you need to understand these things, and then you need to think about it, automate about it. How do you do that? So it is the theoretical
Mm-hmm.
aspects here.
Okay. Got it. Yeah. Yeah. Thanks for
Then
the
we talk
clarification.
about then we talk about observability here. See everything. See, it's not like SRE is separate. When I say SRE, what I mean exactly is these topics, right? These are the things. This is what I mean,
Mhm.
SRE. So this is what we
Okay.
can understand how this happens. So this is the part I'm referring here. Now we talk about observability. We talk about here Prometheus, Grafana. We'll understand what is observability first of all, and we will do observability using Prometheus and Grafana and Elastic Stack. We see, we'll understand how do we set up things, what is the architecture of Prometheus, Elastic Stack, how it works. We will install Prometheus Grafana, we will set up dashboards, we'll
So
understand how
all these are performance tools,
correct monitoring tools.
monitoring tools. Yeah. Okay.
Monitoring tools.
Just yeah.
Now, when you say performance, we have like load generated tools like LoadRunner, Jmeter. Those are also load. They generate load. But when we generate load, we need to understand the infrastructure metrics. We need to understand the logs, all the metrics. So that's why we need monitoring tool. So we call it observability because we can analyze things as well. So these are monitoring, performance monitoring and observability tools. So
Okay.
we will see how do we set up, what is the architecture, how it works, how do we install, set up, how do we create dashboards,
Okay.
how
So
data.
these are open source tools, just like Splunk
Correct,
and
correct,
Dynatrace.
correct, correct. These are open source. That's right.
Okay. Just like Splunk and Dynatrace. Right? Those are the
No,
license.
no,
These are
correct. Those
the
are licensed. Absolutely, absolutely. Yes. Splunk, Dynatrace, AppDynamics, New Relic, Datadog. Those are all commercial tools. We are talking about here open source tools.
okay.
Then we
And
talk
about the
about
Java performance engineering, so the recorded sessions. So what were the topics covered in that one? So is there, how do you show, are you showing by using any like monitoring tool? How would you like, for example, memory utilization or CPU utilization or like any kind of heat map or thread count? So on what
correct.
basis?
You would be seeing JVisual VM here. You would be seeing JVisual VM there. I am showing memory problems using how to take a heap dump. I'm showing there. We'll talk about JVM architecture. First of all, how JVM architecture works, different memory options that we have, memory spaces that we have. Heap is one of them, stack, right? A lot of other memory things we have. How Java programs manages memory. We'll talk about various GC algorithms. From the monitoring perspective, we use JVisual VM. I'm going to show you using JVisual VM. How do you, when a read test is going on, how do you monitor Java process using JVisual VM? You can use any other tools as well, but we'll be showing using JVisual VM. We can take heap dump, analyze using MAT. Uh, so that's what we are demonstrating there.
Okay.
Apart from after this, friends, we talk about databases, cloud databases. we show you what is database options. How do you talk about high availability, performance, various options that we have. How do you make sure the database is highly available? How do you manage performance if you have issues? From the infrastructure perspective, not from the SQL tuning. Okay, SQL tuning is not covered here. This is covered from the infrastructure perspective. So understand the difference. So we'll talk about from the performance from the infrastructure perspective. How do you ensure it is highly available? So we'll understand about the architecture. If the primary node goes down, how would you make sure that you don't get a downtime? You should have a standby database. And we'll talk about something called read replicas. So a lot of options. I'm going to show you create cloud. So we have a lot of options in cloud. If you go to cloud, every cloud has the options. So if you look at the databases, AWS had a lot of options in the database. Why do you use a particular database? We'll talk about this. We have relational database, non-relational database. We have memory DB. Why do we use in-memory database? Key spaces. Why do we use Elastic Cache, DynamoDB? Right? I'll be demonstrating how do you create an RDS instance, which is nothing but the relational database service. Right? So I've enabled the multi-factor authentication for my account. So let me just log in. I am getting the password in my mobile. So you'll be also having this in upcoming weekends. So I was showing the database options, right? So we will show you how do you create a database instance? How do you make sure the storage is never a problem? How do you take care of storage auto scaling? Right. So if you go to the databases, we can create database, and we have so many options in AWS. Within RDS, you have MySQL, Postgre. I'm going to set up, install things, one of the databases, and we'll see options. We'll understand what it is, how it works, different instance type that we have options. So on the databases, friends, that's what we cover in this course, and that's the flow we maintain, friends. Any questions? And it takes usually, friends, 2.5 months to 3 months total.
Will we covering something from the networking aspect as well here, from the cloud
In
networking or
correct,
AWS networking?
correct. So in the cloud part, friends, we have something called VPC. VPC, if you let me show you from the course perspective now. I was not explaining in detail, but we have so many things. So we have, as you can see here, we have VPC. So we'll be covering what is VPC, what is internet gateway, what is subnet, public subnet, private subnet. Do we have all the servers in the public subnet or private subnet? Right? We will talk about everything. So
will we cover about the issues also that we generally get from the networking side?
Correct. We will talk about something called flow logs. How do you get the issue? First of all, you need to enable the logging. So we talk about something called flow log. Flow log helps us identify the issues, first of all. So we talk about that. Yes.
Okay, thanks.
So basically, I'll show you, since you talked about networking, I will just show you one of my PPT slide. Okay. And I'll just tell you that you may not get the entire thing right now. This is the entire repo. I'll be sharing it, Google Drive. You'll be added here. I just keep adding those who get enrolled. Look at this. So many people have got enrolled to this course, and I keep on adding here. So you'll be also added as part of this. You'll be given access. And basically on the networking side, let me show you what you will understand eventually. I'll just show you a slide. Okay. Directly one slide, but we will reach that slide in a very systematic manner, step by step. But I'm going to directly show you the slide, what you'll be learning. Friends, you will be understanding each and everything what you see here in this slide. Not sure how many of you can make sense of it here. A lot of things are here. I don't want to overwhelm you right now by talking about this slide. We have public subnet, private subnet. We have something called internet gateway. We have something called VPC here. We do VPC peering. We use something called NAT gateway. We have something called endpoints. If we connect to on-prem, how do you make sure we connect to the on-prem environment? We have something called endpoints to connect privately. We have flow logs. So right now, it may be too difficult for you to understand, but once we reach here in 3 weekends from now, you would see, okay, you will understand each and every part of it. This is what we cover from a networking side. So this is very important to understand because this is the backbone. In any solution you go, anybody who is using AWS will have this implementation. It's just a generic backbone of any solutions in the cloud. So we're going to understand each and everything. You'll understand why private connections are important than the public because it's vulnerable to security threats. Why do we create private subnet? Why do we need 2 subnets? What happens if I create a server in the private subnet? You don't get public IP. Then how do you access the servers here? All the web server, app server, database server will be in the private subnet. You will not have anything here, those servers in the public subnet. You will only have the external load balancer here. What is Bayesian host, jump server, we call it. We have something called security group, NACL. You'll understand each and everything here. I don't want to overwhelm right now. Don't worry. If you have not understood whatever I told you, need not worry. Okay. That's the flow. Once we cover. Any questions before I start with cloud?
Yeah, Roshan, yesterday you talked about security. Are you going to cover that also, right?
See, security, right? Perspective. We talk about security. See, there are 2 things. Understand. Security of the cloud and security in the cloud. When we say security of the cloud, we're talking about the physical data center that AWS takes care. Security in the cloud, when we deploy the application, security in the cloud is our responsibility. So we'll be talking about security in the cloud. How do you ensure? By restricting user access. If any company, if employee joining a company, what permissions they should have? IAM, security group. What is security group? The firewall around the server. NACL, the firewall around the subnet. You get a lot of things from the network logs, the flow logs that we enable. And those logs are being used by the guard duty and other services. We'll talk about something called WAF, web application firewall, and sealed for DDoS attack. Right. So all these things we cover as part of the course. Security in the cloud. Sound good?
Okay.
Roshan, I have questions like, so can you know what is this GTM and LTM and orchestration?
What is, can you full form, please?
Like global traffic management and local traffic management and orchestration, all this the words comes in the networking, right? So
you need to explore thing. Okay, I never use these words. Can you explore a bit so that I can understand it?
okay.
Orchestration, whatever you're telling.
Yes,
Kubernetes
orchestration and global traffic manager and local traffic manager and proxies and pool members. Generally, just we are come across these kind of words during our we have a tool. In this tool, just there are some dashboards they created, so it's just we use just we are
you need to be
using.
specific. You are just showing something in the, you need to be specific what exactly you need to. These terms are very subjective. If you have a dashboard, what type of dashboard panel you are calling it?
So that
See,
dashboard generally we use to like route the traffic. from the the database center. So we have pods. So if you want to route the traffic from one pod to another pod, generally we do route the traffic at the GTM level as well as the LTM level. So we do it, but we don't have much knowledge about that. Why we are doing about the GTM as well as the LTM level. What is GTM and LTM? All these things.
Okay. I'm not sure about GTM and LTM, what you are defining GTM and LTM, but two parts communication we will cover in this container orchestration. Kubernetes is called container orchestration engine. Okay. So how two parts communicate with each other, we cover in Kubernetes when we talk about architecture and we talk about services, how pods communicate with each other. We cover this as part of Kubernetes. But I don't know what you are calling it,
I
global and
think so.
local.
It shows like GTM like in it is in a traffic across the multiple data centers, and LTM is like in
You're
a.
talking about basically the Route 53. Here in AWS, we call it Route 53. If you have two clusters, primary, and let's say you have one cluster in one region, another cluster in another region, you can route the traffic between the two regions based on the health of the two. If one region is unhealthy, you want to auto route the traffic to another region. We can do using Route 53, which is in AWS service, right? So we have a AWS service. So is that what you're meaning here? Traffic route?
Yeah. It is generally, I think we
we
have
have
multiple data
we have a
centers.
service called Route 53 in AWS, and basically we do this to route the traffic between two regions, two healthy regions. Um, lot of things about Route 53. So we also cover Route 53. Yeah. So we have this. So you need to be like clear. So once you have some understanding of GTM and LTM, we can explore more about it. I need to understand what you're talking about, what you're meaning, what type of communication. So between the two regions, this guy is
It is
going to
like
help us.
GTM is like between the multiple data centers, and LTM is within the same data center. The traffic.
Within the same data center, right? So that's internal communication. And between two data centers, so between I'm talking about Route 53 can help you route between two different regions. In when we say two different regions, I'm talking about across regions. In one region, you have multiple data centers itself. So I'm talking about above that level. I'm talking about two different regions, traffic between two different regions, and each region has got multiple data centers. So I'm talking about that Route 53 as well. So if we'll talk about all those things. So yeah, so just understand. So you need to understand first what is a region, the data center, availability zone, how AWS or any cloud architecture is there, right? So we have got regions. Within that region, we have got multiple availability zones. We call it data centers. Uh, Between the two regions, the traffic can be routed using Route 53. We will discuss about that.
Okay. So what is orchestration?
Container orchestration. That's called container orchestration. Kubernetes. See, orchestration is a word we use in general with automation. Automated way of doing things is called orchestration. Automated way. What is orchestration? If you just Google around the word, orchestration is an English word. It's not a IT word. Okay. It's not a technology. Orchestration is an English word. Orchestration means in IT automation, automated way of doing things. That's called orchestration. So what type of orchestration you are referring? First you need to be clear. I'm talking about container orchestration here. In Kubernetes. So what type of orchestration you are referring? So first you need to be clear what you're asking, Raja.
Got you.
Yeah, hi Roshan.
Yes.
Are you going to cover any basics of chaos here as part of SRE?
Chaos, yes. We cover as part of SRE itself. Yes. Chaos engineering. Basics.
Yeah, thank you.
Yes. If we
And
talk
what
about disaster
tool we will be
recovery,
using for the chaos engineering?
no, it's going to be a generic guideline. It's a basic, I told you. It's going to be a generic guideline. How do we do that?
Okay.
See, I can make a course of chaos 12 hours just for the chaos. So we need to understand what we are solving here. We're solving a bigger picture here. In each topic we can discuss in detail, but we are finding we're trying to cover giving a lot of information here. So chaos course can be there just 8 to 10 hours of the entire session. We can take it up. Terraform could be there for 8 to 10 hours, right? Uh, Prometheus, Grafana can be 8 to 10 hours. We can do that in detail, but we are not doing that. So that's not the purpose here to talk about each and every topic in detail. The point of this course is to understand the roles and responsibility of an SRE engineer and the various important things that you need to know to become an SRE engineer, L2 SRE engineer, level 2, not level 1. Level 1 definitely you would be getting. We are trying to make it level 2 here. So SRE engineers have various levels. Level 1, which works in shifts, 2 to 5 years of experience. Call it like they do could do L1. L2 are the technical persons. So we are trying to make L2 engineers here. So that's why we have so many things in this course. Yeah. Okay.
So, and after this course, can we give a like kind of any kind of AWS certification, Roshan?
Correct. So what we cover here, right? What we cover in the cloud is going to help you go for cloud architect like associate certification, solution architect associate certification, SAAC03. Upon few guidance, I'm going to guide you. How do you want to go ahead? Okay. If you're interested, I'm going to guide you. What you should learn more. But the whatever we are covering 60% already as part of cloud here. And that's the basis. That's going to be your fundamental knowledge that you'll be so strong in fundamentals that easily 40% you can easily learn other things because as part of the syllabus of the certification. From the SRE perspective, from the work wise, when you join a company, that's enough. Whatever we will learn here, that's going to be enough. You'll understand the architecture, you'll understand the services, lot of things we talk about in the cloud. Uh, Not just this, cloud is here also. We talk about EKS here, we talk about databases here. So cloud is spread out. So don't think we're only talking about cloud here. No, we're talking about EKS here. I'll be demonstrating cluster using Elastic Kubernetes Service. I'll be talking about cloud databases here. So a lot of things we're covering in the cloud here. So you were 60% of the solution architect we're already covering. Remaining 40%, I'll be guiding you how do we do that. It's just for the information's sake, so that you don't get lost because you need to learn something else also, like Kafka or how it works from the technology perspective. You need to understand other things.
What
So
is
I'm going
this
to guide you.
Roshan?
It's a messaging broker.
Messaging broker. Okay.
Queue. Yeah.
Okay.
We use it to decouple things. It's a technology. We use it in a lot of places. Wherever high traffic is required, we use Kafka. Think like this. It's a decoupling service. Let's say you have the request coming in. Let's say load balancer and auto scaling group. That's called synchronous communication. If the underlying servers are not working, the load balancer cannot load balance the traffic. The servers has to be running for the load balancer to work. That's called synchronous communication. Kafka gives us options of asynchronous communication, decoupling. So it helps to scale a lot more. Yeah. So I'll talk. I go ahead.
What is the difference between the MQs like RabbitMQ and the Kafka?
It works very much similar. Very much similar. Uh, both are
But
both are the
most of the
messaging.
company use both of them
Mm,
too.
right, right. So there are differences. So, both are similar. I'm saying similar, not the same, right? We have MQ messaging queue also, and Kafka is also for decoupling. For high performance, we use Kafka. Um, we'll talk about in detail. Okay, if I want to explain, right, half an hour I need here to just to talk about that topic for you to get convinced that this will not be the right time. If
Okay.
once we're enrolled and if as a group we want to learn Kafka, I'm going to I will take that as additional sessions as well. But today is not the right time. It will take half an hour for you to understand this. Because I need to
Yeah.
show you the partitions. I need to talk about topic, partitions. How do we do that? Why we talk about it? We'll talk about consumers. It'll take half an hour, okay, for me to understand, for you to understand. Yeah, so let's discuss that some other time.
Yeah. Okay. Thank you.
Yeah. So what I was telling you, you require some additional 40%. I'll be guiding you to get the certification done. But this covers top topic. This course covers 60% of that syllabus already.
Okay. Thank you, Roshan.
Question. I have one question. What is the major difference between this DevOps and site reliability engineer? Okay.
DevOps and
Site reliability engineer. What are the tools? Basically, yeah. The people are telling there will be small layer between the DevOps and site reliability engineer. Okay. People who are completing SRE, where they can do DevOps role.
see, there are two types of role exist in IT. One are called DevOps engineer and one are called site reliability engineers. What is the difference? DevOps primary role is to deploy the code in various environments. Developers develop the code, features, bug enhancements, bug fixes, could be anything. A DevOps engineer primary role is to deploy the code in various environments. Deploy the code in development environment, QA environment. Then there will be QA engineers, performance engineers testing it. Then promote that code once everything gets settled, fixes, promote that code to other environments, pre-prod, performance environment, and eventually to prod. That's the main role of a DevOps engineer. They create CI/CD pipeline. They talk about automation. They create infrastructure in the cloud. DevOps engineer does that because where they would deploy applications, they will deploy the application on the servers. So they spin up, they create servers. So there are a lot of overlap is there between SRE and DevOps. But one very fine difference is that SREs are responsible to make sure production is highly available, production environment. Once the code is deployed, DevOps engineer work completes there. Once the code is deployed, but the real drama starts from there itself because we get issues. Code is deployed, DevOps engineer role can be finished, can be is done, considered to be done. Now you could be a part of a bigger DevOps team. Now there are a lot of companies they do that. They have a part of bigger DevOps team, and they also put few people who look into the production systems. That could be also the case. But on paper, if you look at the DevOps engineer role completes when the code is deployed to production. Successfully, it's running. Now, SRE role starts from there, ideally. So we need to understand the deployment and we need to understand how do we fix the issues. Now, issues, let's say the issues would come like this. Response time getting higher 1 second. Now it should be 200, 300 milliseconds, but now it's becoming 1 second. What would you do? I'm giving one example. Status code. The error percentage has increased. What would you do? We are getting a lot of errors exceptions in the logs. What would you do? So anything to do with production, reliability, availability, security, cost optimization, anything to do in production, anything which is directly related to the user experience. That's the role of a SRE engineer. To troubleshoot. That's why the troubleshooting mindset, the awareness of the technology, the awareness of the architecture. If you're using Kafka, and if you don't know Kafka, you cannot troubleshoot things. If you use a database, if you're using, let's say, Mongo database or RDS database, and if you don't know anything about it, you are not going to help in fixing the issues. So the awareness of all the network or the technical components in the architecture, understanding of the architectural flow, how the request is flowing, the troubleshooting skill sets, and how to fix it. Now to fix it is a very big, it looks very simple. We need to troubleshoot it, but to troubleshoot, you need to have a lot of knowledge. You need to have knowledge on the cloud. You need to know the knowledge on the Docker and Kubernetes because things will be deployed in Kubernetes cluster. You need to know the automation. Sometime this is not something to do with the troubleshooting. This is one of the roles of a DevOps engineer also uh, for the automation purpose. If you want to do automate something, you can do that. But you need to have the knowledge on Docker Kubernetes. You need to have the knowledge on the cloud. You need knowledge on the troubleshooting. How if it's a Java process, how you will troubleshoot things. Knowledge on the observability, databases, and other technical stuff. So anything to do with the production reliability, production troubleshooting. That's the role of an SRE engineer. DevOps engineer role completes when the code is deployed to production. That's the fine difference. But a lot of overlap, technical overlap is also there. Sounds
Yeah,
good.
thanks, Roshan. Thanks for the clarification. Thank you very much.
Roshan, with respect to this context, so I have some questions. So for example, if we get like a high response time or the error status code, like we are getting 500 or something. So so we have like multiple applications developed in multiple languages, and we don't have the knowledge on the applications, and we don't have the like code access. But we have to support all these applications. We don't know the request response mapping sheet. Nothing will be
Yeah,
provided.
why you're saying you don't know? You have everything in the dashboard. See, you don't know code, I understand. Somebody
Yeah.
else have written the code. That's I understand. You can ask for the code repository access, read access. That can be doable. But why you saying you don't know? You have everything in the dashboard. You should know what's the error, what is the response, what is the TPS throughput it was coming, and that's what you need to troubleshoot. You should know the flow. So what you're asking? I'm not
Yeah.
clear. Can you?
Okay. So actually, we have the access for this Splunk as well as Dynatrace. Okay. Apart from that, for the multiple applications, just we use these two tools only. If we want to figure it out, we have to go to the logs and just figure it out. But as an application flow, we don't know how it goes and
Why you
which,
don't know?
because we don't have the access. That is
No,
like an
ask for it. Architectural overview. It's not about access. You should ask for the architectural overview. Performance. May I know your skill sets? What's your role?
basically I'm into like an L2 production support.
L2
So
production support. So
yes.
you need to ask architectural flow. Whatever the solution you are supporting, if you
Mhm.
don't understand the architecture of the application, how are you going to troubleshoot it? How are you going to find the issues? Because you need to narrow down the issue. Without understanding of the architecture of the application, how the request is flowing, what all different components you have along the way of a request, how the request is flowing, if it's coming from this server, that server, going to this database. If you don't know the flow, it is very difficult to troubleshoot. You should ask
Yeah,
for it.
yeah.
You need
That's
to
what we have.
ask. You need to ask people around. You need to. So that's what the exposure. People do not ask because they don't understand what to ask. If you ask the architect, you are expecting me to support this, and you are not giving me the architect overview. How is it possible? Ask for the requirement document, ask for the high level diagram, try to make understanding. If
Yeah,
not, just schedule a
we
call with half an
Yeah,
hour to the.
yes,
Yeah, so,
yeah. I
Roshan,
asked
in
for the
case,
response mapping sheet as well as like in any kind of like in a BRD documents or something. But these guys are
yeah.
telling like it isn't completely agile, so we are not maintaining all these documents. But all these applications were deployed 10 years before. But I think so. These DevOps development guys or the other thing guys are not providing these documents, and my manager is like hopeless.
No, without understanding of those things, without understanding of the architecture, without understanding of the technical components involved, we are helpless, right? You're helpless. What are you going? You're working like a black box. You would not be able to figure out the issue. So
Correct.
first thing you need to understand the architecture. That's the first thing of first rule of troubleshooting.
Yep.
Ask any
Yeah,
performance engineer,
Roshan.
right?
Yeah,
Yeah, yeah.
Roshan, I understand. But we don't, for example, in case we don't understand in the architecture flow, but after what we'll do?
You don't understand
Understand in the architecture flow, for example.
what?
Yeah,
Why would be that? May I know?
yeah. In case, I mean, how to gain the knowledge when the, I mean, how to understand in the architecture when the user send the request and when the receive to.
Correct. So you need to understand how the request is flowing. Let's say you have a three-tier application: web server, app
Okay.
server, database server. Let's say three
Yep.
tier. When
Correct.
you hit
Yeah.
flipkart.com, when you hit Flipkart or makeMyTrip.com, first you hit the web server, right? Then your request goes to the app server. Like I'm just giving you one example.
Yep.
This is the web
Yeah.
server. This is the web component. You hit something here. This is the hit in the web server. The request. Now, if I do Delhi and Bengaluru and this time, it hits the application server. Now, application server performs a logic. It hits the database, gets the information, right? Same thing happens for the retail websites. So you need to understand this flow in the architecture. You may be using Kafka, you may be using a different database, you may be using some other server based on the requirement. So you need to understand that how the request is flowing.
Yes.
Let's say if I go to Google, search for architecture, demo architecture difference. There's so many reference architecture in AWS they have given. So you need to understand the flow, right? How the flow is happening. So that is what we will understand. So using this course, friends, which I was showing you the VPC diagram. So that is the user flow, but from the infrastructure perspective, you can find this. Okay, I'm not so you can find any of the architecture of any website if it's available. If not, AWS architecture has a lot of. So if you go to this AWS architecture, this particular link, let me show you. If you go to this, you will find a lot of architectures here. People have you will find a lot of architecture here in this particular seat. Okay, but link you have a lot of go around the solutions, different kind of applications, healthcare. If you select healthcare, you will find a lot of difference, lot of details you will have here. Technical reference diagrams if you have. So if you just go over one of those two things, you would get to see how the architecture looks like. So we do go over a couple of things so that you understand what could be there. It's like basic stuff, right? So if you have web server, app server, they may change web server, they may use some other web server. They may use some Python. Let's say they may use Django or Flask in the web server, or they may use Spring Boot. For app server, they may use Tomcat or WebLogic. For database, they may use relational, non-relational. So that variation can be there. But eventually the component would be that. You need these basic components to serve your request. You will have databases anyway. So if you go to any of these links, right, you will find the beautiful architecture diagram here like this. Right, and the flow is happening. So you need to understand the flow here. So similar kind of this thing, you need to ask how the flow is happening. So we go over a couple of them. You'll understand the generic architecture that we have. Then once you go and work in your company, you'll understand what is the architecture would look like. So very much similar. See, web server, app server, you need EC2 instance. So once you understand cloud, once you understand various services, the fundamental services, you will understand all these things. You'll have a good understanding. For that to happen, you need to understand the components. If I talk about VPC, subnets, route table, NAT gateway, right? So if you don't understand that, then it becomes difficult, right? So that is where the cloud knowledge, because all are cloud services, they're using cloud services, and without knowledge of cloud services, it will be big, it will be difficult for you to understand. Like, say, let's say using Kinesis. So where is Kinesis is like it's very much similar to Kafka here. So you need to understand these things, why they would use this open search. So it is again a database. Lambda is the function of the service. So once you understand these things, DynamoDB is a database. So once you understand these things, you'll be able to understand the architecture flow a bit.
Okay. But to get the better understanding to support the production services, we should need to get the architectural flow as well as the request response mapping sheet, all these things, right?
Not request response mapping, at least the flow, definitely how the flow is happening.
Yeah.
Right? When I hit flipkart.com, what happens? Where the request is going? After that, how I'm getting to display this page? Why I'm getting this page? From where the things are getting retrieved? So you need to ask these questions for your website, for your applications. Are we hitting database? When are we hitting database? What all information are there in the database? Do we use in-memory database as well or not? So right. So you need to ask, you need to explore these things. I think you have never looked into the architecture. That's what I think most of the confusions are happening. Yeah, the understanding of architectural flow is the first rule of troubleshooting. Without understanding of that, we cannot troubleshoot things.
Yeah, so we asked all these documents. These guys are telling like go to Splunk and explore from this Splunk. So how the logs are flowing and all these things. This is what they are telling.
No, that doesn't work like that. Do you have any flow diagram dependency? Can you ask this question? How do you figure it out? Show me the HLD diagram. So give me the high level diagram that you have prepared or the architect have prepared. So you need to ask this question from the Splunk. How do you figure this out all by yourself? Do they have do they have mapping kind of a thing where they can see the request response, like how the request is flowing? Do you have a diagram like that? If you don't have it, very difficult to understand all those things. So you need to ask, okay, they are just making excuses, is what I'm trying to understand, is what they're doing. They are just trying to dodge the questions. They're just making excuses.
Sure, Roshan. Yeah, thank you.
Hi,
So we
Roshan.
have okay, yeah, please.
Yeah.
Go ahead.
Hi, Roshan. Srikanth here. Yeah. Hey, I just have couple of questions which I wanted to clarify. So basically, the SRE is more of proactive, right? Right. So we have to think. I mean, we have to think. I mean, we have to avoid the future kind of issues, right? I mean the people,
Correct.
right? The guys, right? They react when they see issues, but here we have to try avoiding all the future kind of issues, right? That's what SRE plays. Right?
Correct.
Plays it. Okay.
But even if the issue happens, what would you do? That has to be also be ready.
Okay.
See,
I
you
got
try your best. You try your best not to get the issue, but you
okay.
should have also plan B. Yeah.
Okay. Got it. When issue comes, what to do, right? So what to do,
Yeah.
how to handle that. So let's say we got a issue, production issue today. So the SRE, he is the one who is going to jump first and understand the issue, and he will try to fix it. If it is something which needs to, I mean, if it is something which he cannot do it, or which he, I mean, for any reason, so he'll have to route it to the
Correct.
concerned team.
The
Correct?
right team. Yes,
Right.
he's the gatekeeper, right? We need to bring in developers or DBAs in the call, right? So definitely. So first point of contact to filter out the issues, to understand the impact, right? So that then talk to the right team members. Correct. All the team members. Production is a overall company's goal, making sure production is highly available. It's
That's
a
true.
company goal. Yeah.
Yes. That, I mean, if I mean, it's all business loss, right? I mean, when they see issues, I mean,
Correct.
any, right? Yeah. So other thing is, as an SRE, what tools I need to be strong, right? Language, Python or PowerShell. And tools wise, I am a PT guy and I worked on PE as well, and I'm good with AppDynamics, Dynatrace, and I'm kind of very good at solid experience in LoadRunner as well, Roshan. So what tools are really needed, right? I mean, to have hands-on or
So
more more.
what I've understood, right? You are good at monitoring tools, observability tools. You
Mhm.
are worked as PE, so I believe you should have a troubleshooting experience,
Okay.
how to understand the issues. So what I think you should know about how cloud architecture works,
Okay.
how the solutions are being developed in the cloud, various cloud services, and how the cloud architecture looks like. and various services that we use. And I think Docker Kubernetes, if you have not worked on Kubernetes, so Docker Kubernetes, uh, that would be on the tools perspective. And on the automation perspective as well, you need to understand from the SRE role how Terraform works, how Ansible works, and on the programming language perspective, see, we need to sometime automate on Selenium, not Selenium, Shell script. Okay, not Selenium. Selenium is a QA tool. Shell script, I wanted to say. So shell scripting, because we work on Linux systems, so shell scripting is must, and Python scripting, which is beyond. Let's say Python is going to be always the ever learning thing. It's not like nobody can say it's completed. So if you're not able to get a solution in Terraform automation or Ansible automation or shell scripting, Python should be the way to learn to go forward. That's what I would say. I would suggest you for your career. Yeah.
Okay, got it. So you mentioned Terraform, Ansible, and you mentioned something else, right? What is the other one?
Shell scripting, Python scripting,
Okay, Shell and Python.
cloud and Docker and Kubernetes.
Yeah, okay. I have a knowledge on Kubernetes, Kubernetes pods, right? Containers. I haven't, but I've not, got chance to,
And you need to understand how disaster recovery works. What is DR? What is chaos? The various terminology that we use. How do you handle disaster recovery?
Okay.
How do you do chaos testing? You should have a good understanding, because in production we need to test it. We need to be thorough with our testing. We purposefully fail servers here and there. We need to prepare for our disaster recovery. So all these things are important.
Okay, got it, got it. So SRE is basically framework, or it's a concept, right? It can be, I mean, it will be used everywhere, right? Any industry or for any application, correct?
When you say any industry, means I could not get it. It means
Eh,
IT industry only, right?
Yeah, IT meaning see, different. I mean, industries meaning banking, finance, different departments.
Yeah, that does not matter. See, it's just making sure production is highly available, reliable, secure, highly performing, cost optimized. That's what the main focus of SRE engineers are.
So it's basically a concept or a framework that can be used anywhere for any
See,
application.
it's not a framework, or it's a skill sets. Okay, site reliability engineering. Whatever see, what is performance engineering? So you only talk about performance, right?
Correct.
That will performance engineering. Now reliability engineering, to make sure it is highly available. What all things you will take care to make your production system highly available? What all things will you take care to make sure its reliability? Issues will happen. Will it bounce back automatically? Will it recover automatically? That's called reliability. Will it be secure? No, the solution that you're giving, or do you have cost optimization measures? So all these things comes under reliability engineering.
Got it. Yeah. And so tuning part will also be involved here.
Correct. We can suggest our tuning. We can suggest, if you see performance issues, why not?
Okay. The only final question that I have is, we have different teams which take care of application, right? So why are we seeing too many production issues? Is there any reason? I mean, is it because of we are missing something, or is it because of?
See, very difficult. If you are a performance engineer, you need to agree. How much ever we try to replicate production environment, production load, it's very difficult to manage or replicate all the production scenarios.
Okay. Any reason for that? Because we don't have time, or is it because we don't have skill?
See, it's not about time, or production is a different ball game. In low environment, things are controlled. You put load in a controlled manner. You know what you're putting.
Okay.
In production, things we cannot figure out what all could go wrong. Think like that, right? I know how to bowl, how to bat, how to field. It doesn't make me a best batsman, right? The depends on the ball, right? It depends on various scenarios, right? So where the issue is happening, right? Nobody can guess. If the more you guess, the more you do chaos testing, it's better. So it doesn't mean that if you know how to bat, you can bat all the bowlers, right? Same thing. How much ever you try to replicate issues, it's not possible to replicate all the issues because of the data volume, because of the load. All those things matter.
Got it. So this is something like, assumption or going on with some experience, right? But you won't be able.
I'm not able to understand what is your question. We are discussing in length. Can you be specific? Can you ask your question?
No, I got it. So
Yeah,
the question that I asked,
yeah.
yeah, go
We
ahead.
need to start
Roshan
with our
from
topic. We are
Yeah, I got it.
yeah,
can be
I have,
specific.
Roshan, I got it. Please go ahead. Yeah.
Cool,
Mm.
cool.
yeah, Roshan, from my side, I have one doubt. For example, in case I am joining the organization, if any new tool implementation, I mean, how to start and gain the knowledge and what are the teams coordinate? Like, I mean, what are the steps I followed? Any suggestions for me or any knowledge share me?
I'm not could not. Could you repeat your question? I could not follow
Yeah,
exactly
for example,
what you asked.
yeah, for example, in organization I joined. Okay, if any, I mean, new tool implementation, monitoring tool like CoreLogic, like any other some monitoring tool
Hmm.
implementation. Okay, I mean, what are the steps we did? We do follow that. Any suggestions for me as far as SRE we
No,
followed?
see, not about the tool. Every tool, see, we need to capture metrics. With the tool that you are trying to set up, any tool, be it Splunk, be it Dynatrace, AppDynamics, is the tool giving you all the information? Is it the tool? All the issues are all the metrics are being captured. Or are you missing anything? Whether you're able to capture all the metrics of all the components involved or not, right? So those things matter. So capturing all the metrics, logs from all the servers that you have, like web server, app server, database server, you may have pods running. So are you able to capture all the metrics which can help you troubleshoot issues or help you understand the health of the application, right? With
Mm.
able to capture the logs, how long you're able to hold the logs for, all these things. Same, all the tools work on the same way. Very similar approach. The way we collect the metrics, the logs. So all the performance monitoring tool, we have to make sure we are able to capture the metrics as well as the logs for all the from all the components involved.
Okay, hi Roshan. I have one
Yes.
Okay.
query.
Mhm.
Yeah. So we are going to discuss this chaos engineering part, basics, right?
Yeah, yeah.
Disaster recovery. So can I assume during our sessions we'll have an application, demo application, and then we are injecting some faults and we can see how it is
No, it's a
working.
basics. It's a basic. As I'm explaining you, it was a basic. I'm going to let you know how do we do that.
Okay, in
It's
AWS
it's
through
it's not a
FIS.
hands-on. It's not a hands-on here.
Okay.
Everything
Mhm.
else is hands-on. This is not the hands-on. I was
Okay.
explaining that, right?
Okay.
Everything here is hands-on,
And when
except
while
this.
explaining this Docker and Kubernetes, so we are going to deploy some application in this, right?
Exactly, exactly,
Okay, so
exactly.
we can use this application for this
We
disaster
can, you
recovery.
can, you can do that.
Yeah. Okay. Sure. Thank you.
Roshan, like just for my understanding, can we say that earlier we used to have something like production support teams who used to take care of any production issues, troubleshooting across production issues. Mhm. But still,
They were
so
support team. They were not troubleshooting. They were contacting just. They were just
no,
contacting developers to
there used
fix
to
it.
be
Yeah.
there used to be something like L1, L2, L3 supports.
Yeah, yeah. Same thing.
Even like
SREs are there. Correct. Yeah.
yeah. So
Same.
probably some of these production support teams they were not having the enough knowledge of performance engineering concepts. Probably can we say that SRE is something like it's bridging gaps between various teams, and instead of having various teams we have someone like who has multitasking abilities, something like a production support team plus deployment team plus development team, a kind of having overlapping knowledge across all these areas, but do a specific role like where they actually handle the reliability of production.
You are correct. You are correct. See, we are trying to make L2 SRE engineers here, level 2. Level 2 means you are a technical guy. You can troubleshoot the issues, you can narrow down the issues. But if it is beyond the scope of your knowledge or if you beyond of your domain, if you think this issue can be resolved by a developer who has developed the code, we need to bring that person around. So we need to understand, we need to fix, first of all, the platform. There is something called platform engineering. So the SRE engineer should be very good at platform engineering. This should at least the infra level issues needs to be resolved by the SRE engineers. There is no excuse there from the
Yeah.
infrastructure perspective. Now, if the issue is with the code, now developers have written the code. SRE engineers do not own the code. Because they have not written the code. Oh, the code is owned by someone else. But if you know upon troubleshooting analysis that the issue is with the code, now SRE engineer is responsible is to involve that guy. Because there are so many developers, so many teams. We cannot bring everybody in the call, right? Throughout in the entire organization, there has to be somebody who should be narrowing down the issues.
Yeah, who can do at least initial 50%.
Initial
And
50% of the analysis
yeah,
and get the troubleshooting started with the right intent to solve
yeah,
that, contact the right person and fix the issues if it's infrastructure related issues or scaling issues, right? And or other issues, but the code fixing. Yeah.
yeah, got it. And one more thing, we are hearing this SRE role like last 3-4 years maximum, and before that we never heard about this role. So can we say that this SRE role came into picture after the introduction of like a cloud evolving of cloud like across various organizations?
Exactly, because cloud has made a lot of jobs redundant.
Mm.
There used to be Linux admin earlier. There used to be DBAs earlier. Now, when I talk about cloud, you'll understand most of the things are automated. Linux admin, DBA, all those jobs. Do you see those jobs now? No,
Yeah, exactly. Yeah,
because cloud has automated most of the stuff. That is why so much of expectations is there from one guy, because a lot of things cloud has automated. But there are other things from a reliability perspective that cannot be automated. So that's why you are right in your thought process that because of the emergence of cloud automation and performance engineers nowadays are getting transition to SRE engineers because performance engineers have that troubleshooting mindset. Only thing that performance engineers were working in lower environment, controlled environment. Now they are being exposed to work on production environments.
yeah, yeah.
Even you are
So
a
even
performance engineer, you would be even asked to look into the production issue. Let's say some issues have come.
yeah,
You, a performance engineer, may get notification, right? That, oh, what did you test? The issue is still there. Can you look into this, right?
yeah, yeah,
Because performance engineer simulate the production load and give the sizing requirements that we need this much of sizing. I don't know the scope, but ideally performance engineers is supposed to simulate the production load and give the sizing requirements, auto scaling. But if you don't understand auto scaling, if you don't understand Kubernetes, how would you give the sizing? So this course is not only for the SRE engineers, it's also for the performance engineer if you want to become a cloud performance engineer. If you have never
yeah,
worked on cloud, never worked on Docker, never worked on Kubernetes, how do you do your job properly as a performance engineer in the cloud environment? This course is for them also.
yeah. And one more thing, can we also say that like performance engineers, yeah, they do tune the code, like basically they do monitor the code, probably providing tuning sessions, all those things. But there is a limitation still for performance engineers from probably from knowledge perspective, from various access perspective. And that is where this SRE is actually bridging that gap in terms of knowledge or in terms of access or in terms of even the product idea about production systems. So that limitation is also getting covered with SRE and complexity of cloud infrastructure. Probably that is also adding up.
See,
Can we say?
performance engineering, if they know about cloud, if they know about Docker, Kubernetes, if you know about, so that performance engineer is as good as SRE engineer if that mindset has come to operate in a production environment. So there is no, if whatever you have mentioned, performance engineering, let's say the traditional performance engineer plus cloud knowledge, plus Docker, Kubernetes knowledge,
Mm,
if you club those things, the guy will become SRE engineers. That's what we are trying to talk about here.
yeah, yeah, perfect. Yeah, that makes sense. Yeah, thanks, Dr.
Great.
Roshan, let's
Friends,
say we
we
have
are taking up a lot of questions, so I think we will not be able to start any topic today. Go ahead. Yeah.
just one question. Okay, so we have let's say we have 200 services in AWS, right? So do we need to, how many services we need to be strong at? Like 20 services,
See, as
30?
part of this course, we are covering 25 services, 20 to 25 services, the most commonly used, and that is what would be used in any architecture. In most of the architecture, there will be always something new. You will find that whenever you join a company that you can easily learn and understand. But we are covering about 20 to 25%, 25 services of the
Got it.
services. Yeah.
Yeah. So do we need, I mean, if in case if I want to do certification, right? What is that? I mean, what is it better to do? Like cloud or in the cloud side, what is it better to do? Like associate engineer or
Solution architect associate certification would be fine. SAC03.
oh, S2 what is that code? Sorry.
SAC03 solution architect associate.
AC03. Okay. Got it. Thanks, sir. Thanks for that.
Okay. Friends, are we done? All good? This certification.
Okay, got it.
We call this SAC03. Okay, friends. So I wanted to start the cloud. Let me just introduce you to the cloud, friends. Okay. Now, see, the first topic that we have in our course is cloud. Okay, and that's what we're going to learn about the cloud part, the first part. What do you think the cloud is, friends? I must have explained you yesterday to some extent, but I'll just talk about. See, this is what we call a data center. Okay, a data center. Earlier, let's say whenever. Okay, I see one question in the chat. If was that a question or Sai? Was that a question? You have already are good, Sai, or you need to read about it? What you have messaged
No, no,
something
no,
in the chat?
no, no, no. I just explained what I understood.
Okay,
So
cool.
we already discussed. So we can
Okay,
ignore that.
perfect. Okay, thank you. Okay, see, this is what a data center is. What is a data center? Think like in the outskirt of a city, multiple acres of land. You have to, somebody has to purchase, construct the building infrastructure, and purchase this kind of servers. The laptop is also a server which has some core processor. Just think billion times that servers. So just think like that, how many servers we're talking about here. Storage, not just the server storage. That's what we call a data center. Earlier, like any company has to deploy an application like Amazon.com. They have set up a data center, Oracle, IBM, HP. Facebook has a data center. They keep on adding servers on daily basis. They have purchased a big land in the outskirts. They keep on adding servers on daily basis because their user load is increasing. So this is what I call a data center. Now, if you own it, when you say own it means, or the company where you work, the company owns it. We call it on premise. It involves billions of dollars of investment, purchasing the land, procuring the land, constructing the facility, purchasing all the servers, maintaining security of the premise. You have to employ security personnel to take care of the facility. The servers may run out of may run out of electricity, so you need to make sure you have everything backup. So you see this powerhouse, right? In power grid here. So you need to make sure you never run out of electricity, never run out of internet in this kind of facility. Servers may not work, so you need to make sure you have maintenance in place. Somebody is replacing it. So you lot of things goes into investment. We call it on premise. No, not everybody can afford this. So what do we do that? A lot of companies, they have invested in such kind of data centers and they have a business model. So all the cloud providers that we see around, AWS, Azure, GCP, Alibaba, DigitalOcean, right? All those things, they have this business model. It's like they have a bigger shop, friends. Now you have a shop, right, in our nearbys. Similar to that, it's a shopping thing, right? So they have this business model where they have set up multiple such data centers, hundreds of data centers across the globe. And if you need the servers, because not everybody can afford to set up such data centers, so you can rent it. If I need, let's say if I have business idea, Swiggy or any application, if I have some application business idea, I need the servers to deploy my applications. My user base may increase. I need more servers also going forward. So I will leverage these data centers. So when you leverage the data centers, you use like a rent. You don't own anything. It's like staying in the rented apartment. I can stay in the rented apartment as long as I pay the rent. The day I stop paying the rent, I'm not authorized to stay, right? Same thing happens for the cloud. They own the everything. You can use it, server, storage, databases, they have a lot of services to offer. We'll talk about it. You can use it. They have some cost associated. You need to pay the bill and you can continue to use it. That's the cloud, friends. So that's the difference between on-prem and cloud. So there is no difference in the data center perspective. Whether if you own it, that's on-prem. If somebody else owns it and you rent it, you leverage it. That's called cloud. That's the simple definition of cloud. Simple. Now, what AWS have done, they have got a lot of infrastructure, friends. If you look at AWS global infrastructure, if I show you, they have got a lot of such data centers. They call it availability zones. Basically, if you look at the availability zone is defined as one or more discrete data centers. Think like one data center has one AZ. So they have 114 data centers across the globe. They are present in 36. They have 36 regions. Like this is the presence, friends. What I'm showing you is the region. This is the AWS launch regions, 36. The red ones are coming soon. In each region, they have got multiple data centers, multiple AZs. In India, also, they have two regions. One is in Mumbai, one in Hyderabad. If you look at the Mumbai, they have 3 availability zones in Mumbai. In Hyderabad, also 3. Usually, they have 3 availability zones. 3 data centers in Mumbai. Why do they have it? For high availability. We'll talk about this. Why do they have multiple AZs in one region? The way they have architected themselves, in such a way that they support high availability, friends. This is how a region looks like. Multiple data centers, multiple AZs in one region. Why do they have it? Now these AZs are distance apart. Think like Mumbai or Hyderabad. These regions are distance apart. Some 150 miles, 200 kilometers apart. Why do they have it? Let's say if a flood comes, if all are nearby, all the data centers will be flooded and downtime you'll have them. Because flooding, nothing, earthquake, you cannot help with those things. You will have downtime, services will not be operational, and all those things will happen. So the reason they have it is that they encourage customers to use multiple availability zones. I should have the servers here also, servers here also, servers here also. Let's say web server. We should deploy in such a way that we leverage multiple availability zones in one region. My web server, app server, All those things are present not just in one AZ, because if one AZ goes down, I will have downtime. See, we need to avoid downtime. And the way to avoid downtime is to leverage all the AZs of the region. Use all the data centers. Have servers here also, here also, here also. Even if one AZ goes down, you have two AZs up and running. And then we can load balance the traffic across the load balancer. Right. So what, let's say now, let's say let's say somebody wants to get a server. I want the server, I want the storage. The entire Netflix is AWS, they use AWS, friends, to the entire Netflix, the content that you are, they store AWS storage service. Now, for example, let's say you want the server. So what is the procedure? So the best thing is that you need to create account in the cloud. You should have an account in the cloud. I'm going to guide you. How do we do that? And you have been given access. It's not like you have to call data center, you call the call center and get servers. No. Everything you get it. It's like a shopping mall. You log in, get whatever you want. Get server, get storage, get databases, whatever you want. Get it. You will get bill. You will get bill, you need to pay the bill. Everything is through the cloud console. You will use it the way you want it. They are not going to restrict you, suggest you. You'll get monthly bill, you'll get full detail of the bill, why this bill has come and all those things. You'll get all the details of the cost. You can explore where the cost is like a postpaid connection. You get all the details. If you don't pay the bill, you'll be not operational. They will stop you getting logged into the server, this console. So you can create an account and you can get whatever you need. You could be in the remotest part of the country. You could be in a village. If you have a laptop and internet connectivity, you can create servers in across anywhere. I can create a server in Tokyo, Sydney, because they are available. They have the availability zones, they have the regions there. You could be in the remotest part. If you have internet connectivity, a laptop, you can create the complete infrastructure. That's the power cloud gives us. And we need to learn this. How do we learn these services? How do we create server, storage, networking, load balancer, auto scaling group? We have so many services. In databases, we have so many options. In containers, we have so many options. And that keep on developing. Cloud is going to stay, friends. It has automated a lot of things, made already quite simple things around. We have a lot of storage services, security services. We'll talk about a lot of things in the course. So that's a brief, friends. I just wanted to get you started on the cloud part. We'll be going in full throttle mode from the next weekend, friends. Okay. That's all for today from my side.
Roshan, I have one last question. So with respect to the data centers, for example, if we have like a data center in Mumbai and one another data center in Hyderabad, if a
You
guy
have
logs,
three availability zones in Mumbai, 3 in Hyderabad.
yeah, okay. Just for example, okay, if we have like 3 AGs in Mumbai and 3 AGs in Hyderabad, if a guy logs from Bangalore or some other area from Vizag, then the call, how it goes, how it knows it goes to Mumbai or Hyderabad.
No, you will log in to a console like this. If you want the server to be created in Mumbai, you will select Mumbai. You will select Hyderabad and then you will operate there. You will create server, you will deploy application. Then if somebody, let's say you install flipkart.com in your application, then somebody hits flipkart.com, how the traffic flows, how the reach is a different story. We'll talk about that. But you will select the region, and you will create server, install application there. That's what you
Yeah.
do. You log into the console and then you operate from here.
Yeah. I understood. But I'm asking the second question which you told. So, for example, a user logged in from different locations, then how the call goes, whether it goes to like Mumbai or Hyderabad, is
No,
there any?
no. You are not. So first of all, you need to ask that you have used Hyderabad. You have an application deployed in Hyderabad. Let's say
Mhm,
Hyderabad.com, whatever it is. You have
mhm.
deployed the application, and if somebody hits from US or Australia, how the request is coming.
Correct.
Is that your question?
Yes, sir.
So it is same answer. Like if you hit Amazon.com, how the request is going from my laptop to US. Same answer.
Okay.
I'm hitting make my trip. Make my trip. I don't know which region they have deployed it. How my request is going. So we will discuss about this. First, you hit the domain name. Domain name is make my trip is a domain name. Domain server resolves. They give us the load balancer detail. Then my browser makes a call to the load balancer. It hits the load balancer and the load balancer sends the request to the server. Server hits app server, database server, and that's how the traffic we get the response. A lot of things happens.
Okay.
So yeah. It's same as like how do you hit a website? What happens?
Correct.
How
Here,
when you hit a
yeah,
website, what happens?
yeah.
Yeah.
In this context, so my question, I think I didn't ask the question clearly. So in this context, if there are two data center regions are available, then how the call can decide to go whether it goes to hit the Mumbai or go to hit
So
the.
let load balancer handle it, right?
Okay, that's what my question. Yeah.
Let load balancer handle it.
Okay.
How the request will be routed, which server is having less work. Let load balancer takes care of that.
Okay. Yeah.
Rohan?
Got it.
Yeah.
Roshan, I have
Roshan,
one.
it's
Sorry,
Roshan.
sorry. Roshan. Yeah, Roshan.
Roshan,
So
I
yeah,
have one question.
Mhm.
Oh, okay. Okay, go ahead, please. Yeah.
yeah. So let's assume that there is no data center in India, okay, and the user is sending a request somewhere in India, okay, maybe Hyderabad or Mumbai, wherever, right? So let's say in that case, since there is no data center, it will go to the nearest one, right? Maybe it's in Singapore. Let's say they have a one in.
No, who tells you nearest one? If my website,
Mhm.
let's say Amazon.com, I have deployed in US.
Okay.
Let's say Amazon.com or any US website. Think like any US website. I'm giving, let's say, example, abc.com, whatever it is.
Mhm.
The server is in US. Why it will hit Singapore?
Because see that data center is far away, right, from India.
So
So
why it will hit
let's
Singapore?
that's a closer data center to India. I'm just
My
I'm
server,
just
you're not understanding my point.
Mhm.
If the server is in US, why it'll my request will go to Singapore?
No, I'm just saying they have a data center in Singapore. They don't have anything in India.
Okay, so you are telling abc.com is deployed in Singapore.
Correct. Singapore, US,
Fine.
and London also. Okay, let's assume that.
Okay, three places. Okay,
Mhm,
then it will choose the best latency. Wherever we have the less network latency, Route 53 has that capability based on the best list
mhm.
network latency. The request will be routed to that specific data center.
Got it. Got it. Okay. Yeah, you answered my question. Thanks for that, Roshan. Yeah.
Roshan, I have one question. Um,
Hmm.
let us say most of these infra will be in the cloud service providers side, right? Like for example, AWS, it is managed by Amazon, and they have their own cloud setup, and that is where the infra lies. So that is where, like, if it is shared between various companies, probably that is where we call it as like public cloud. And maybe if it is managed through separate VPC, maybe and they have that setup in their Amazon data centers itself, and then it
Hmm.
is private cloud. So if, for example, uh, we have basically, if someone sets up a data center within our data center, within our company's data center itself, if they set up a cloud, Is that
You
possible?
have confused me. Okay, Sai, I don't
Okay.
know.
No.
You keep it
What
simple. Yeah.
what I am trying to understand is it possible for any company to set up a cloud within our company itself, within our company data centers itself?
No, if I own a company, Amazon.com, I have decided to use a data center for myself. Why I would allow anybody else? You need to
Okay,
take my permission.
understood. My understanding is wrong. Okay, fine. I got the point. Yeah. So when we say private cloud, it is managed through VPC, right?
No, Guru.
No, that's
Private cloud is private to the. It's like
Um,
your own on-prem thing like that. Like
um,
you are not allowing anybody public private. So don't get confused. Public means public. AWS is public cloud means you can also create a server in Mumbai, and I can also create a server in Mumbai. I can deploy my application. You can deploy application. That's called public cloud.
hmm.
Private means I am the only one can use the data center.
So it is in on-prem.
No, on-prem, whether you, yes, mostly on-prem, but there are other providers. They give you, like people purchase private cloud also on rent basis. There are situations, but mostly think like on-prem. I am the only one using the data center. That's called
Yeah,
private cloud.
I got the point. Exactly, my question is in that. So you mentioned, right, there are companies which can provide infra, people, all those things, right? But
Hmm.
all that infra will be on the cloud service provider side,
Hmm.
and they will rent it.
They will rent the entire data center.
That is also called private cloud. And even if we are having the cloud setup in
See,
on-prem, that is also called
public
private
private
cloud.
means I am the only one using it, like private.
Hmm. So it has
Like
two ways of
you can
setting.
hire a private taxi, but
Okay.
you are not the owner of the taxi, but you are the only one using it at that time.
Hmm.
You have sharing taxi also. So that is the concept.
Okay. Then that is a private cloud. I understood the concept. Basically, it is the only one we are using. We are the only one who is using that infra. Then it is private cloud. So
Yeah.
that what we are saying is private cloud can be set up in such a way that the infra, people, everything belongs to the service provider, and it is in their data centers. But we will rent it. That is one option of private
Hmm.
cloud.
Yeah.
And second
There
option
are
is
companies, there
people.
are companies who does this, There are companies who provides the entire data center as private. Okay, you are the only one using it. Okay, use it.
Yeah, that is one option. Second option is that we can also have a cloud setup in on-prem. That is also called as private
Yeah,
cloud,
we
right?
don't use the word cloud setup. We have a data center. We will own a data center. That's called your own data center. Don't use the word cloud there.
Oh, okay. We are okay.
Like if you own the data center, you are only going to use it, right? Why do you are using the word cloud?
Okay. I got it.
It's
Yeah,
on-prem.
it is on-prem. That's it.
On-prem.
Roshan. So in the real time, do we see multi-clouding? Let's say a application is residing in
People do that. People can
do that.
leverage AWS, Azure, GCP, multi-cloud option is also there. On-prem plus cloud, hybrid cloud model is also there. Multi-cloud is also there. A lot of such things are there. Yes.
Oh, okay. So in that case, we would be seeing more issues, Roshan, because one application is set up in AWS,
See,
another
first of
application.
all, they are deciding based on some
Mhm.
requirement, right? They want to
Okay.
be super highly available. They don't trust one AZ. Not just that,
Mhm.
they don't even trust one region, right?
Okay.
They are gonna multi-region, but they are also going multi-cloud option. So it's not about issues. If everything is set up, right? It's all about communication network. If everything is set up, networking thing is set up, one and the same. Some network latency will be there. That's all.
Mhm.
So
Okay, got it. Thank you for that.
okay, friends, good. So we have just started our course, friends. So I hope everybody has understood the way we have planned this course. We make it super interactive, super super learning, right? In step-by-step manner. Okay. So that's about me, friends, and about the course. Let's meet next weekend. Thank you so much.
Roshan, whom I need to get in touch to get the training?
You need
Training.
to get in touch with Mr. Kumar. If you go to the website from Isha, if you go to this link, there is a number given in this link. Mr. Kumar, okay, from Isha. So you need to contact him for the enrollments, understand more about the timings. I have already covered. Technical things you can ask me. Um, this is the number of Mr. Kumar Gupta. Please get in touch with him. I'll say the link here again.
Okay, and it's a 1 hour class on a daily basis, 5 days, right? 5 days, Monday to Friday.
My goodness. No, no, no. Who told you like that?
I'm just assuming. Okay, I'll talk to Kumar then.
No,
Okay.
no, no. Weekends. We have
Oh,
been
it's only.
talking Saturday and
Oh,
Sunday.
oh, that's good. That's good. Okay, fine. Then I'll get in touch with Kumar to
Here is the
understand.
timing. Okay. Here is the timing. So we are on day 1 today.
Okay.
And we will be mostly meeting 2 hours, 7:30. For initial days, we do it for 1 hour next Sunday. But Sunday is going to be, if you look at this 9th March, we're going to be 2 hours, 7:30 to 9:30, Saturday and Sunday, 4 hours a week. That's what we follow. Saturday and Sunday, 2 days in a week.
Okay, got it, Roshan.
Correct. IBM provides Aman. Yes, that's right. IBM does have that option. IBM, HP, they do that. Yeah. Okay. Thank you so much, everybody. Let's meet next weekend and discuss further. Thank you so much.
Thank you, Roshan.
Thank you.
Thanks, everyone.